All right. Please let me know if I'm clearly audible and clearly visible. Good afternoon, everybody. Welcome to class. Okay. Good afternoon, welcome to class, and welcome to Unacademy's YouTube channel. My name is Hafsa Malik, and I'm your top educator for psychology on Unacademy for the NTA-UGC platform. Who is this? This is also me. Today we will talk about an overview of the most important neurotransmitters. आज मैं आपको थोड़ी सी quick information दूंगी neurotransmitters के बारे में, chemical substances, chemical messengers which carry out neurotransmissions, or which are the main component which is exchanged in postsynaptic potentials. कौन से inhibitory हैं, excitatory हैं, what are neuromodulators, all of that I will give you a quick overview and we'll get started. All right. Good afternoon. Good afternoon. Good afternoon, everybody. Very, very happy to see you all. Happy Friday to everyone. Last day of the week, working day of the week. All right, चलिए start करते हैं. Let's get started. Let's get started quick. This is a little bit about me. This is what Unacademy offers. If you're subscribing, please use code Hafsa Live. I've just started a new sort of batch for GATE and UPHESC short course for about a month, over a month. You can come join in and learn from me. Use the code Hafsa Live when you do subscribe to Plus or Iconic. This is my Telegram group. You can join it for further updates. Special classes every day at 7:30 p.m. on Unacademy, and on YouTube you have 7:30 p.m. Wednesday and Friday 3:45. All right, let's go. Chalo. Now, do we understand the parts of a neuron? I have taken an earlier class. मैंने इससे पहले यहाँ पे class ली है on YouTube, where I have explained the various parts of the neuron to you and the types of neurons. Neurons के क्या-क्या types होते हैं वो भी मैंने आपको explain किया है. All right. Okay. Good evening. Good afternoon. हाँ जी. Absolutely. So there we have seen that this is the dendrite part, right? Actually only the branches. ये जो आपकी branches आप यहाँ पे देख रहे हैं, ये आपके dendrites हैं. ये जो है सेल बॉडी है, राइट, द इनर पोर्शन ऑफ इट, यहाँ आपके सेल ऑर्गेनेल होते हैं. नाउ फॉर आवर न्यूरोट्रांसमिशन, सी ओनली द डेंड्राइट्स and the axon actually, or the terminal vesicles, and the interaction between the presynaptic and the postsynaptic neuron is what is important here. Presynaptic का मतलब है जो न्यूरॉन एक्चुअली साइनेप्टिक गैप में पहला वाला न्यूरॉन होता है, ठीक है, जिसके टर्मिनल वेसिकल से न्यूरोट्रांसमिटर्स आ रहे हैं, और आपका दूसरा न्यूरॉन वहां पे कनेक्ट जो होता है उसकी डेंड्राइट्स इंफॉर्मेशन अपने अंदर लेती हैं. All right, so you have a pre-synaptic neuron, you have a post-synaptic neuron, and we will see how they exchange information and how this information comprises of the chemical substances known as neurotransmitters and what actions do these neurotransmitters bring about. ठीक है, तो हमारे लिए क्या क्या important है? We today are going to focus on the terminal vesicles and the dendrites. Now we know कि axon पे क्या होता है? The all or none potential travels through what? The axon only. Actually over the nodes of Ranvier. ये जो आपके nodes of Ranvier हैं, यहाँ jump करता है आपका action potential. Action potential is all or none, right? And is electrical in nature. Now we will talk about how, because the neurotransmitters are chemical in nature, therefore the transmission between one cell and another, जो एक न्यूरॉन और दूसरे न्यूरॉन में इंफॉर्मेशन एक्सचेंज होती है, उसका नेचर केमिकल होता है, क्योंकि न्यूरोट्रांसमिटर्स ही एक्सचेंज होते हैं. ओके, ऑल राइट, एब्सोल्युटली. चलिए, then neurotransmitters are obviously chemical substances. They act very 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 quickly, or are they slow acting? आपको क्या लगता है जब न्यूरोट्रांसमीटर रिलीज होता है एक्सन के टर्मिनल वेसिकल से दूसरे न्यूरॉन के डेंड्राइट पे, तो क्या ये स्लोली एक्ट करता है? आज आपने न्यूरोट्रांसमीटर दिया तो कल एक्शन होगी. इज इट लाइक दैट, or does this action happen really quickly? How does it happen? Very very quickly, really fast. Absolutely, very good, very good. This happens really quickly. All right, now let's see when they do reach the target site, what all do they do. So I'm going to draw a lame drawing over here, but this will help you understand a little bit better. तो ये आपके dendrites है ना, ये जो branches मैं अभी draw कर रही हूँ, these are the dendrites. Now these dendrites are only capable of receiving information from the previous neuron. Let us say यहाँ से हम transmission start कर रहे हैं and these are my terminal vesicles. Right? Neurotransmitters are either going to be stored here or they're going to be synthesized here. या तो न्यूरोट्रांसमीटर बनते ही यहाँ हैं थोड़े न्यूरॉन्स में, या तो सिर्फ यहाँ पे हम स्टोर करेंगे. लेकिन न्यूरोट्रांसमीटर्स जो भी सब्सटेंसेस होते हैं यहाँ पे सिंथेसाइज करके या स्टोर करके हम यहाँ से दे देते हैं. राइट? सो कैन आई कॉल दिस द प्री साइनेप्टिक न्यूरॉन. मतलब जो साइनेप्टिक कनेक्शन बनेगा दो न्यूरॉन्स में, ये उससे पहले वाला न्यूरॉन है. दिस इज द फर्स्ट न्यूरॉन. ओके, सो वी कॉल दिस द प्री synaptic neuron. All right? Okay. ठीक है. Now here we will have neurotransmitters coming out. Neurotransmitters. And you have the synapse over here. इसी को कहते हैं synapse या synaptic cleft, which is a functional space which is formed between one neuron and another while they are exchanging information. तो यहाँ हम एक दूसरा न्यूरॉन ड्रॉ करेंगे. Okay, where you will have dendrites. Okay, so ये आपकी dendrites हैं which are actually going to be taking in information. All right. Okay. So these are your dendrites, right? Okay. ठीक है. Fine. तो neurotransmitters यहाँ पे चले जाएंगे. Now, what kind of action can neurotransmitters bring? Is it always going to be the same action? Synapse या synaptic cleft में हमेशा क्या हम एक ही तरह का neurotransmitter देंगे? Are we going to put out only one particular type of neurotransmitter? And therefore, the kind of action that should be brought about in the post-synaptic neuron, will it always be the same? No. 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 Not like that. Not like that. Let's try to understand why and how and what. So you will either have excitatory neurotransmitters. थोड़े से ये substances क्या होते हैं chemicals? ये excitatory होते हैं. मतलब ये दूसरे न्यूरॉन पे जाके वहां का depolarization start करते हैं. ठीक है? तो if it is excitatory in nature, it's going to lead to a postsynaptic potential which leads to depolarization. समझ रहे हैं आप? ये पोस्ट साइनेप्टिक पोटेंशियल कैसा लेके आएगा? जो डीपोलराइज कर दे दूसरे न्यूरॉन को. All right. Now these are all going to be responsible for post synaptic or graded potentials. Can I say? न्यूरोट्रांसमीटर्स का काम कहाँ पे आता है? ये कहाँ पे होता है? Graded potentials. These are not all or none anymore. मतलब जितनी stimulation उतना effect. All right. Very, very good. All of these are graded potentials, whether excitatory, inhibitory, or neuromodulatory. Now, if my neurotransmitter, absolutely, if my neurotransmitter which I am giving out is actually inhibitory in nature, then what happens over here? फिर भी हम depolarize कर देंगे next neuron को. अगर हमारे neurotransmitters जो हम synaptic cleft या synapse में दे रहे हैं, वो inhibitory हो? No. Then they will cause hyperpolarization. They will cause inhibitory postsynaptic potential. And they will therefore hyperpolarize the next neuron. They will hyperpolarize the next neuron. ठीक है? इससे क्या होगा? This will reduce the likelihood of action potential occurring in the adjacent or the postsynaptic neuron. All right. Now, some neurotransmitters will neither show excitatory function or sometimes show excitatory, sometimes show modulatory function as well. अब यहाँ पे आप सोचो कि memory synthesize हो रही है, memory consolidate हो रही है. So, glutamate is going to be our primary excitatory neurotransmitter. In addition to that, you may also have acetylcholine, which is actually going to help and serve as a catalyst. न्यूरोमॉड्यूलेटर वो न्यूरोट्रांसमीटर होता है जो एक्चुअली दूसरे न्यूरोट्रांसमीटर के इफेक्ट को एनहांस करे. ऑलराइट, सो एसिटाइलकोलाइन विल एक्चुअली हेल्प the effect or the excitation of glutamate spread faster, spread wider, and therefore. All right. So here you have neuromodulators which will only enhance or change the effect of another neurotransmitter. All right. Okay. ठीक है. Okay. चलो. Hopefully we've understood. Please let me know if we have. Okay. If there are any doubts also, please ask. चलो ठीक है. Now, excitatory neurotransmitter, primary excitatory neurotransmitter is glutamate, and its primary role is where? Glutamate, primary excitatory neurotransmitter, it is found throughout the central nervous system. Although excess quantities are not great, this has a very important role to play in learning and memory. इसका learning और memory में बहुत important role. Okay, all right, fine. Then you can see acetylcholine, which is actually excitatory also, which is inhibitory also, and which is a neuromodulator also. Okay, acetylcholine excitatory भी होता है, inhibitory भी होता है, और neuromodulator भी होता है. And its most important role is again in memory, learning, new learning, and motor movements. Again, you will find this almost throughout your central nervous system. इसको भी almost आप सारे central nervous system. In fact, you will find this is one of the most abundant neurotransmitters throughout the body because this helps us perform motor movements. आपको end plate potential याद है that we have done before? I think last week we have done it in special or here. So in with regards to motor movement also, acetylcholine is very, very helpful. All right, wonderful. चलो ठीक है, ठीक है. Now, histamine here is related to immune function. So, it is excitatory also and it is a neuromodulator also. It actually weakens the infection site so that when inflammation occurs in the infection site, histamine will go and break down the barrier and try to attack and try to isolate the area. Now, dopamine here, very, very important. Can I say for reward learning? Dopamine, very, very important for reward learning. Any experience of pleasure, and therefore it is an excitatory neurotransmitter also. It can be inhibitory also, and it is a neuromodulator also. It is one of the very, very, very important neurotransmitters. आप देखेंगे dopamine का role काफी disorders में भी है, and excess is associated with schizophrenia, although this is not the only reason. And then less dopamine is often associated with movement disorders, dementias, like Parkinson's. All right. Okay. ठीक है. So dopamine, neuromodulator also. Then where else this has most of its role is in reward learning. Histamine, we'll write immunity. Reward learning and motor movement. If you have to, reward learning, experience of pleasure, and smoothing of motor movement. All right, ठीक है. Then we have norepinephrine or noradrenaline. Now we know that this brings about sympathetic activation. ये हमारी हार्ट बीट को इंक्रीज करता है, ब्रीदिंग रेट को इंक्रीज करता है, आईज को प्यूपल को डायलेट करता है. सेम. Epinephrine as well as norepinephrine will actually bring about sympathetic activation, fight or flight response ये लेके आएंगे. Sympathetic activation. और क्या करेंगे ये? They will bring about, same thing only, fight or flight response is nothing but your sympathetic activation. चलो, ठीक है. So that is our excitatory neurotransmitters. Then we have GABA or gamma aminobutyric acid. With the help of 6-glutamate decarboxylase, something decarboxylase, we are able to synthesize from glutamate gamma aminobutyric acid. And this is our primary inhibitory neurotransmitter. This is found throughout the central nervous system. ये almost आपके हर neuron के terminal vesicle में synthesize होगा, right? And this is very, very important actually for inhibition Sometimes we need to stop movement also, especially with smoothening of motor movement. Smoothening of motor movement. You will see basal ganglia ka there is this one part, globus pallidus, which mostly secretes gamma aminobutyric acid so that motor movements get smoothened out. Hanji, absolutely. So smoothing of motor movements. And then what else does it do? Can I say it also reduces anxiety and restlessness? ये हमारे over worrying या excess worrying को कम करता है. Yes, it has an inhibitory effect and therefore it makes us more relaxed also. Relaxed and reduction of anxiety. Anxiety और worry ये reduce करता है. ठीक है? Okay, wonderful. Then serotonin is mostly inhibitory and it is also a neuromodulator. Like norepinephrine is also a neuromodulator. Serotonin is mostly inhibitory but also a neuromodulator. Now we know that serotonin's role is mostly in the maintaining of mood. Mood maintenance, yes? And then sleep related function also. So somewhere it enhances learning also, but mostly it helps us in regulating our mood. All right. So it does play somewhat of a role in learning and stuff also, but that's about it. That is about it. If you guys have any doubts over here, please let me know. I'll just explain to you what monoamines are and what catecholamines are, and then we are done. बस हम एक बार monoamines और catecholamines और indolamines का review करेंगे. That's it. Clear, ma'am. Chalo, theek hai. No doubts, ma'am. All clear. Chalo. Thank you so much. So same thing is repeated here also. It's just that you have or I have put up here what drugs actually mimic the effects of which drugs are relevant over here. Okay. So what are monoamines? What category of neurotransmitter is this? Monoamines are actually made from a single or synthesized from a single amino acid. Synthesized from single amino acid. And there are two categories. One is catecholamines and another one is indolamine. Indolamines are synthesized from tryptophan and catecholamines are synthesized from tyrosin. This is the amino acid, essential amino acid, जो फूड के थ्रू हम इनटेक करते हैं. तो टायरोसिन से क्या क्या बनता है? इससे एक्चुअली बनता है आपका पहले एल डोपा बनता है which converts to dopamine, which then is synthesized into norepinephrine. This is not always the process. This is how it is done, especially in the adrenal area. Okay, then we have epinephrine. ठीक है, तो ये तीन जो हैं आपके, these are known as catecholamines, whereas tryptophan is used to synthesize serotonin. All right, it's used to synthesize serotonin. Absolutely. We'll also go back and put up sites of synthesis. हम sites of synthesis मतलब कहाँ कहाँ ये एक एक neurotransmitter actually produce होता है वो हम लिखेंगे. ठीक है, that will help you remember better as well, and then I will attach it to your notes. Any doubts here? Please let me know. This is quite simple actually. We've done this before as well. Monoamines simply means that ये neurotransmitters एक single amino acid से बनते हैं. Catecholamines वो हैं जो टायरोसिन से बनते हैं. तो यहाँ पे आपका डोपामीन है, नॉरएपिनेफ्रिन है और एपिनेफ्रिन है. एक ही चीज, एक ही सब्सटेंस जो एल डोपा है वही सिंथेसाइज होती है डोपामीन में. डोपामीन फिर सिंथेसाइज या कन्वर्ट होता है नॉरएपिनेफ्रिन में, फिर ये कन्वर्ट या सिंथेसाइज होता है एपिनेफ्रिन. Okay. Okay, wonderful. So we'll quickly look at glutamate is actually synthesized in most cells of the central nervous system in the terminal vesicles. Same as with GABA. ऐसा कोई specific site नहीं है. For dopamine, although there is substantia nigra, which is one of the sites, which is one of the primary sites. For serotonin, there is raphe nuclei in the brain stem. And there is locus coeruleus. Okay, locus coeruleus again in the brain stem for norepinephrine. Please remember these. इस पे questions आते हैं. हाँ जी. With that, we're actually done. Again, if you have any doubts, please ask. Otherwise, happy Friday to you. I hope you have a great day. Okay. I suppose we are done. We are done. All right. I just wanted to give you a quick overview. Next हमारी YouTube की class Wednesday को होगी 7:30 बजे. Have a great weekend. Thank you for learning with me. It is always a pleasure to talk to all of you. If you do want to go ahead and subscribe, don't forget to use the code. And that is about it from me. If you like my classes, go ahead, subscribe, click on the bell icon, like and share and all of that. Bye guys.